Picture the universe in your mind, an expanse so vast that even light takes billions of years to traverse. It's an awe-inspiring thought, isn't it? Now let's dive a little deeper. The universe, as we understand it, is estimated to be around 93 billion light-years in diameter. And within this almost incomprehensible expanse, there are billions upon billions of galaxies. Each of these galaxies is a bustling metropolis of stars, with estimates suggesting that there could be over 100 billion galaxies in the observable universe alone. And around many of these stars, planets circle in a cosmic dance, just like our Earth orbits the Sun. The number of planets in our universe is staggering. Just in our Milky Way galaxy alone, scientists believe there could be as many as 400 billion stars, many of which are likely orbited by at least one planet. If we extrapolate this to the entire universe, the numbers become almost too large to comprehend. But with such a vast array of celestial bodies comes the question, could Earth really be the only planet with conditions suitable for life? Statistically, it seems improbable. As our technology improves, we're discovering more and more exoplanets that exist within what we call the habitable zone of their star. This is the region where conditions might just be right to support liquid water, a key ingredient for life as we know it. These discoveries are exciting because they suggest that there could be countless Earth-like environments out there in the universe. And if these planets have similar conditions to ours, it's possible that they could support life. So when we consider the sheer scale of the universe, with its billions of galaxies, stars, and planets, the idea of life existing elsewhere becomes less of a question of if, and more a question of where and how abundant. Given the sheer number of planets out there, the possibility of Earth-like environments elsewhere in the universe becomes a tantalizing prospect. Life, as we know it, is a complex dance of molecules, a dance that is not exclusive to Earth. The ballet of life begins with basic building blocks, organic molecules. These fundamental components of life, such as amino acids, the building blocks of proteins and nucleotides, the building blocks of DNA and RNA, have been found in the most unexpected places, in the vast, cold void of space, in the inky darkness of interstellar clouds, amid the frozen silence of comets, and tucked away on distant planets and moons within our very own solar system. Scientists have discovered these organic molecules. These findings suggest that the chemistry of life is not a performance limited to the stage of Earth, but one that might be playing out across the cosmic theater. One of the most fascinating theories about the spread of these building blocks is the panspermia hypothesis. This hypothesis proposes that life's ingredients could have been cooked up in the cosmic kitchen of space and then delivered to Earth via comets or meteorites. Imagine that. The very molecules that make up you, me, and every living creature on Earth could have journeyed billions of miles through space before finding a home on our planet. But the panspermia hypothesis doesn't stop there. It also suggests the reverse could be true. Life's building blocks could have originated here on Earth and been flung into space by asteroid impacts, ready to seed other planets with the potential for life. The discovery of life's building blocks in space and the intriguing possibilities of the panspermia hypothesis open up a new perspective on the existence of life beyond Earth. If the ingredients for life are scattered across the universe, who's to say the recipe hasn't been cooked up elsewhere? The presence of life's ingredients in the cosmos suggests that the recipe for life might not be unique to our home planet. The universe might be a vast cosmic kitchen filled with the potential for life. The question is, where else has the recipe come together? Life on Earth is tenacious, existing in places where we once thought impossible. Let's take a journey to the edges of existence, where life defies the odds and thrives in conditions that would destroy most organisms. These hardy life forms, known as extremophiles, are found in some of the most hostile environments on Earth. They live in scorching hot hydrothermal vents deep beneath the ocean, endure freezing temperatures in the polar ice caps, and survive in highly acidic or alkaline environments that would dissolve ordinary cells. These extremophiles are a testament to life's adaptability. They've evolved unique biochemical mechanisms to survive and even prosper in conditions that would be fatal to most other organisms. Their existence broadens our understanding of the potential environments where life might exist. If life can flourish in the crushing pressures of the deep sea or the radiation-blasted soils of Chernobyl, then it's possible that it could also exist in environments that we might initially deem inhospitable. Let's think about it. There are moons in our own solar system, such as Jupiter's Europa and Saturn's Enceladus, that have oceans beneath layers of ice, subjected to extreme pressures similar to Earth's deep sea. If extremophiles can thrive in such conditions here on Earth, it's not a stretch to imagine that similar life forms could exist on these icy moons. And what about Mars? The red planet is a harsh, arid world with a thin atmosphere and intense radiation. But we know that certain extremophiles on Earth, known as radiotolerant organisms, can withstand high levels of radiation. Could similar life forms persist on Mars? The existence of extremophiles on Earth opens up a fascinating new perspective in our search for extraterrestrial life. They teach us that life can adapt in ways that we're only beginning to understand, pushing the boundaries of what we thought possible. They show us that life is not only adaptable, but also incredibly resilient. If life can thrive in Earth's extreme environments, who's to say it couldn't on other celestial bodies? Water, the lifeblood of Earth, might also be the lifeblood of the universe. It's a bold statement, but one that finds support in the relentless pursuit of scientists to unveil the mysteries of the cosmos. Water is more than just a thirst quencher. It's a universal solvent, a transporter of nutrients, and a key component in most of the biochemical reactions that take place within living cells. In essence, water is indispensable for life as we know it. Now imagine the implications if water were found elsewhere in the universe. It would hint at the possibility that life, in some form, might exist beyond our planet. And guess what? Scientists have found evidence of water in various forms in places far removed from our blue planet. Take Mars, for instance, a planet that's long been the subject of extraterrestrial life debates. The Mars Reconnaissance Orbiter and Mars Science Laboratory have provided compelling evidence of water ice beneath the Martian surface and the possibility of liquid water in the past. Then there's Europa, one of Jupiter's largest moons. Underneath its icy crust, scientists believe there's an ocean of water twice the volume of all of Earth's oceans combined. And let's not forget Enceladus, a moon of Saturn, which also appears to harbor a subsurface ocean of liquid water. And the water trail doesn't stop within our solar system. Far beyond, in the atmospheres of distant exoplanets, scientists have detected traces of water vapor. These discoveries have ignited a spark of hope and curiosity, prompting us to reassess our understanding of habitable zones in the universe. But why all this fuss about water? Because where there's water, there's the potential for life. Water's unique chemical properties make it an excellent medium for biological processes. So, the discovery of water in any form on a distant celestial body significantly enhances the likelihood of finding life beyond Earth. The presence of water, a key ingredient for life as we know it, points to the potential for life elsewhere in the cosmos. Indeed, as we continue our cosmic voyage, the search for water remains a beacon guiding us in our quest to answer one of humanity's oldest questions. Are we alone in the universe? In the search for extraterrestrial life, we are not just looking for green men, but for signs, or biosignatures of their existence. Biosignatures are indicators of life, such as certain types of gases or molecules that might be produced by living organisms. Scientists are utilizing advanced technologies to probe the atmospheres of exoplanets in search of these biosignatures. Through methods like spectroscopy, they analyze the light from a star as it passes through a planet's atmosphere. This allows them to identify the chemical composition of the atmosphere, potentially revealing the presence of gases like oxygen or methane, which on Earth are linked to biological processes. While the detection of these gases is not definitive proof of life, it adds another piece to the puzzle, suggesting conditions that could potentially support life. As our technology and understanding evolve, we get closer to answering the age-old question, are we alone in the universe? The hunt for biosignatures might soon provide us with compelling evidence of life beyond Earth. Our search for extraterrestrial life is propelled by our technological prowess. We've come a long way from the first telescopes that gave us a glimpse of the cosmos. Today, advanced telescopes like the Hubble Space Telescope and the forthcoming James Webb Space Telescope pierce through cosmic dust and peer into distant galaxies, revealing exoplanets and interstellar bodies. Space probes, such as Voyager and New Horizons, have embarked on ambitious journeys, pushing the boundaries of our solar system and sending back invaluable data. The Mars rovers, like Perseverance, seek signs of past life and pave the way for future manned missions. In the realm of radio astronomy, projects like SETI and Breakthrough Listen scan the skies for potential signals from intelligent extraterrestrial life. Each of these advancements enhances our ability to explore the cosmos, bringing us closer to answering the profound question of our cosmic solitude. As our technology advances, so does our ability to answer the age-old question, are we alone in the universe?